September 30, 2009. Red Planet may be better known as the Wet One, by Kenneth Chang. If, in 1976, NASA's Viking 2 lander had been able to dig about 4 inches deeper into Mars, it would quite possibly have made an important and surprising discovery: water ice far from the polar regions and not far below the surface. Instead, that finding waited until 2008, when scientists saw what looked like buckshot and powder burns on the surface of the planet, the scars left by a meteorite that struck sometime in the first half of last year. Following up with a closer look at this and other fresh impact sites using the high-resolution camera aboard the Mars Reconnaissance Orbiter, scientists spotted 5 tiny craters, just 1.5 to 8 feet deep, containing bright blotches, ice. One of the blotches was large enough that the orbiter's instruments could definitely identify the material as water ice. The craters lie just a few hundred miles from Viking 2. Within months, the bright areas faded and disappeared as the ice vaporized into the atmosphere. "It is pretty darn cool and surprising," said Kenneth S. Edgett of Malin Space Science Systems in San Diego, a member of the team that made the discovery. The findings appear in the current issue of the journal Science. The presence of water on Mars has long been known: ice at the poles, water vapor in the atmosphere. But only in recent years have scientists gotten a better idea of how much and how pervasive the water is. From the observed rate that the ice vanished and computer simulations, the scientists concluded that the ice was 99% pure water instead of a half-and-half mix of ice and dirt, as they had expected. The ice in the mid-latitudes was also closer to the equator than had been expected. That points to a higher humidity in the Martian climate, perhaps just thousands of years ago when the ice formed. Last year, the Mars Phoenix lander, digging in the Arctic regions of Mars, found 2 types of ice: the very clean ice and a dirty mix. "We assumed the clean ice was anomaly and speculated how it could have formed," said Selby Cole of Washington University in St. Louis, another member of the team. "Now we see on the other side of the pole multiple incidents of very pure ice. So it looks like pure ice is the rule, and the little bit of dirty ice we find at Phoenix is actually the anomaly."